Welcome back. So the goal of this video is going to be to think about the key empirical challenge facing Kruger and Angrist and some of the strategies we might use to get around that challenge. So as we talked about, the ultimate goal of this research is to estimate the return on investment in education. And in order to do that, what this paper is going to focus on is trying to estimate the relationship between a worker's education and that worker's earnings. In other words, what we would like to know is that for you, if you chose any level of education, how would that level of education affect your earnings? Or another way to think about it is, if you decided to stay in school 1 year longer than you would otherwise, how much more would you earn as a result of that decision? So in our theory work, right, we've thought about this by thinking about the relationship between your adult earnings, W2 of H, and your human capital investment. And we've said that you've got some sort of relationship like, say, AH to the B, right? So AH to the 1/2 or something like this. So essentially what we want to know, right, this is going to tell you for any level of H you choose, what earnings are you going to get, right? And our key strategy for trying to get at something like this is usually going to be some sort of regression, right? So we could say if we could think of a linear relationship between W and H, we could estimate that using a regression, and then we can say, oh, great, now we know these parameters, we know how your human capital investment is going to change your earnings. So making this linear is actually fairly straightforward, because if we take a log here, the log of AH to the B is going to be equal to log of A plus B log of H. And so we might think, great, we can estimate this relationship by running a regression where the dependent variable is going to be our log earnings in period 2, and our independent variable is going to be our human capital investment, our level of education. Okay. So the goal would be, if we estimated this relationship, right, because the true effect of an extra year of education, or log education, on log earnings is given by B, that we would end up with beta 2 equal to B, and beta 1 equal to log of A. Now, this would work if what we had as our data was a bunch of people who were completely identical other than their level of ability, right? In other words, if we had the same level of ability for everyone, then indeed we could just say that the log of that average level of ability would be a constant in our data, right? Or even better, if instead of having a bunch of different people, we saw you in a bunch of different alternate universes where you'd chosen different levels of education, then we would really be able to say that this is estimating the relationship between the level of education you chose and the earnings you end up with. The fundamental problem is, if people have different levels of ability, then this regression might not work. In other words, the fundamental problem we're going to run into is that people who have higher levels of education might have had different earnings to begin with than people who end up with lower levels of education. In other words, the fundamental problem is that education isn't random. In our simple model, we've seen this because when we try to estimate the amount of education workers are going to get, that level of education is going to depend on their ability, right? So if we try to say that we're going to choose education by maximizing the present discounted value of your lifetime earnings, right? So something like W1 times 1 minus H plus 1 over 1 plus R times, say, 2A H to the 1/2, right? As we've done before, when we maximize this, we're going to get W1 equals 1 over 1 plus R times A over H to the 1/2. H is going to equal A over W1 times 1 plus R all squared, right? This is what we've done before. Well, what this is going to mean is people with higher levels of education in this model are also going to have higher levels of ability, right? And because of the fact that they're going to have higher levels of ability, we would expect that their earnings would be higher even if they didn't get any higher levels of education. In other words, a high ability person with some fixed amount of education would still have higher earnings than a lower ability person with some fixed amount of education. Because those people are going to get different levels of education, we're going to end up overestimating the effect of education on a worker's earnings, right? If the result is from bias from ability. So if we ran a regression like log of W2, right, equals beta 1 plus beta 2 times log of H, beta 2 is going to give us both the effect of education and the effect of higher ability. Okay, so how can we go about trying to solve this problem? So if the fundamental problem that we're facing, right, is that people who have higher levels of education also have higher levels of ability, how can we try to solve this? How can we get a consistent estimate of the effect of education on a worker's earnings? Well, the first strategy we might try to use is to control for ability. In other words, if we were able to measure the ability of every worker, then maybe we could say, instead of comparing workers with high levels of education to workers with low levels of education, let's try to compare workers with high levels of education, workers with low levels of education who have similar levels of ability, right? In other words, try to compare workers that look the same other than in their level of education. Now, the problem is there's several challenges to actually implementing this strategy. So the first problem with this is, if we wanted to control for ability in the real world, we wouldn't just need to control for one thing, we would have to control for many things, right? So if we gave workers an IQ test, right, and said this IQ test is going to measure your ability, that would maybe capture one aspect of what leads to some people getting higher levels of education than others, but it wouldn't measure things like your patience or your persistence, your willingness to get up in the morning, right? Your study habits, all of these other things that are going to increase your earnings and also potentially increase your education, right? So even if we just wanted to control for ability, we would need to throw in a massive number of controls, right? Analytical skills, social skills, much, much more than just a single thing that we would call ability or IQ or something like this. On top of that, even if we completely controlled for everything we might call ability, by which we mean everything that's going to increase your level of education, but also increase your earnings in the future, we would still run into the problem that people who get more and less education, who have similar ability, must be different in some other way, right? Something must have pushed some people to get more education and some people to get less education. So if it is an ability, maybe it's going to be things like family resources, right? People who have more money available to them as young people are going to stay in school longer than people who have less money available to them as young people. But those family resources might also affect your future earnings, right? Because it's going to affect your social connections or your knowledge of the workforce or all of these other things that help people earn more money, right? Maybe staying in school longer or shorter is going to reflect something like your career goals or aspirations. But again, this is going to affect your future earnings. You know, a health shock, it's going to affect your future earnings. So the problem is, if we tried to control for everything that would be related to both education and earnings, we're going to, A, need to measure an unbelievable amount of stuff about people, stuff that we would never be able to measure, and B, we would have to say, well, we must be leaving something out if we aren't going to completely eliminate all the differences in our data between people with higher and lower levels of education. In other words, we would have to end up left with something that affects your decision about how much education to get that we don't think reflects what your wages would be given a certain amount of education. So an alternative strategy, right? This is not something we're going to really expect to be able to do. An alternative strategy would be to perform an experiment. So I get a bunch of people, maybe a bunch of college students like you, and I somehow convince you to let me flip a coin. If the coin lands on heads, you'll stay in school for 1 year more than you would otherwise. And if the coin lands on tails, you'll leave school. So we'll end up with some people getting heads, staying in school for an extra year, some people getting tails, staying in school for 1 year less than they would otherwise. And the only reason that one group stayed in school and one group didn't was because of the result of this coin toss. And because of the fact that we don't think that that coin toss should affect your earnings other than through its effect on education. In other words, we don't think that the people who got heads are smarter on average than the people who got tails, or richer on average than the people who got tails, or in better health on average than the people who got tails. Because it was completely random who was in one group and who was in the other group, we're going to believe that if we see differences in earnings between people who got heads and people who got tails, that's likely to be the effect of education. In other words, what we could do is we could run a regression that looks like this, right? Log earnings is going to equal beta 1 plus beta 2 times whether you got heads, right? And in this case, beta 2 should only reflect the effect of getting an extra year of earnings, right? Heads results in 1 more year of education. Beta 2 is going to measure the effect of an extra year. And the reason we're going to believe that beta 2 measures the effect of an extra year of education is because there's no differences between people who got heads and people who got tails other than their level of education. In other words, because it's random who's in one group or another, we don't need to worry about all of these sources of bias. Now, of course, this is a little bit fanciful, right? It's going to be very, very difficult to convince people to stay in school for an extra year just because of the result of a coin toss. And it would be very unethical, right, to force people to leave school or force people to remain in school in order to perform an experiment. So this isn't really possible, but if it was possible, this would get us at the estimates that we need. So in the next section, we're going to talk about how Angrist and Kruger use real data from the real world in order to simulate the results of this experiment.